everyone. It is fabulous to be here. I'm looking around at the audience and seeing a lot of friends and people I've read over the years, and so it's really fabulous, and I'm looking forward to your comments and questions. I want to give a special thank you to Brian for being such a great warm-up act for me. I have to say that this work was not published in Science, and I'm not sure it ever will be, but I'd like to talk to you about some ideas that I've been thinking about for a long time and developing over a number of years, and research program around these ideas. How many of you know about transactive, well maybe I should say, how many of you don't know what transactive memory is? Okay, great, thank you. Okay, see? So, transactive memory is a theory about group-level cognition and information sharing. And transactive memory systems often develop in relationships and groups where there is interdependence. People divide up responsibilities for different knowledge areas, and they share information about that knowledge. And what ends up happening is that people have less responsibility for knowledge across the team because they can specialize in one area, and that people can rely on one another for information. There's been a lot of research on transactive memory over the last 10 years, especially in team contexts. And a lot of that research suggests that transactive memory systems are beneficial, that you want them in teams because they're efficient, they're effective, and a lot of work has looked at how to promote transactive memory in teams. And so I've always thought, well, maybe there are some downsides to transactive memory systems, and maybe there are some distortions and biases that can arise as transactive memory systems develop. And so I've been thinking about it in the context of errors in transactive memory. And so I'd like to talk a little bit about some of my thoughts on this topic. And I do want to mention that when we talk about errors, errors don't always have negative consequences. That in fact, sometimes errors can have long-term benefits. So let me give you an example of what I mean by an error. And this is an example of a transactive memory error for over-specialization. So this happened a while ago, and it was a satellite mishap that was blamed on a human error. So San Jose, California, a $239 million satellite toppled onto a flat factory floor last year because nobody bothered to check that it was secure before moving it, according to a NASA investigation board's report on the mishap. And then at the end it says that errors were also made by other team members who were so narrowly focused on their individual tasks that they did not notice or consider the state of the hardware or their operation outside those tasks. So here was a situation where people specialized in certain areas, but they didn't have a sense of sort of the overarching view of the project. And so when one person didn't fulfill their task, there was nobody to step in and correct it. Okay, so what I'd like to do is answer three different sorts of questions related to errors in transactive memory systems. The first is, what information needs to be shared in teams in order to avoid errors? So you do want some specialization that brings efficiency, but people may also need to have some shared knowledge across people that will help prevent errors from occurring. And then also, what errors arise on the basis of people's perceptions of the transactive memory system, and who knows what and where that knowledge resides. And lastly, are errors made by experts more likely to be missed than non-experts? So if you have people specializing in different areas, and they're sort of assigned responsibility for that particular area, is that a less likely situation for people to recognize and correct those errors? So maybe experts may actually lead to errors being missed. So I do want to talk just for a minute about transactive memory. Transactive memory theory was developed by Dan Wegner, and unfortunately Dan Wegner passed away earlier this year, which was really a tragedy for the field. he proposed in 1995 a computer network model of transactive memory. So it was based on sort of the model of individual cognition and memory that was applied to a group setting. So basically, a transactive memory system is a set of networked computers with a shared directory system. That's how we described it. So transactive memory systems involve structure, content, and process. That there is some information that is differentiated within the team. So some information resides on individual computers, and then some resides on all the computers. So this is a very sort of network approach to thinking about transactive memory systems. Also, transactive memory systems also have, there's different kind of content of knowledge regarding some information is specialized, some information is common to all members of the system, and that there are different processes involved. That the directory, the central directory is updated where people sort of have an idea of who knows what, that information is allocated to the expert, and that when people need information in other areas, there's a retrieval coordination process. So transactive memory is about structure of knowledge. It's about the content of knowledge, what's shared and what's unique, and also processes. So one thing to keep in mind, though, is that humans are not computers. You know, there's not perfect transfer of information. People make errors, and errors can go undetected. And I would argue that, especially in transactive memory systems, where people have, assigned areas of expertise, that there are a lot of reasons why in transactive memory systems errors may be even more likely to go undetected. So transactive memory, as I mentioned, has been shown in a number of different contexts. The early work has looked at transactive memory systems in the context of close interpersonal relationships, where there's high levels of interdependence and a lot of shared decision-making. Looked at work teams, emergency response teams, hospital teams, project teams, scientific teams, and laboratory research groups. So it's been shown to exist in a wide variety of contexts where there's interdependence among people, and that there's some motivation for people to specialize in different knowledge areas. So again, the questions are sort of related to the content, what information needs to be shared to avoid errors in teams, what errors are made on member perceptions on the transactive memory system, that's really related to the structure and where the knowledge resides, and then finally, are errors made by experts more likely to be missed than non-experts? And so I'd like to talk a little bit about research that relates to each of these questions. And the first one looks at, I just want to describe a study that looks at the degree to which information is shared across all members versus differentiated or differentiated so that some information is, all the information is distributed across members. And so one of the things that we did in a study is we had groups perform two different tasks. One task where they had to learn a lot of information in a short period of time, and then the second task was they had to apply that information in a novel context. So they had to answer knowledge questions, trivia questions, that related the information that they learned in the first part to another task. And so the first task, it would be most efficient for people to divide responsibility, we thought, for different knowledge areas and to specialize. And in the second part, when they got trivia questions, they would remember only their small section and be able to apply that knowledge. So we manipulated the transactive memory type, whether it was a completely integrated system where all members of the team learned the same information, or whether it was distributed where members each specialized in different systems, by using an instruction that groups do better on the second task when members divide responsibility for learning in different categories as equally on the first task. So we asked them to divide responsibility. When groups divide the responsibility of learning information, it's more likely that one of the members will be able to answer the question correctly. So, and in the second, we said that groups do better on the second task when all members try and learn all words across all categories on the first task. So when group members learn the same information, it's more likely that one of the members will be able to answer question correctly. And interestingly, what we found is that in the situation where groups learned all the information, they had more correct answers, and they also had less errors in their memory. And in this study, what we coded errors as incorrect answers, when people would answer the knowledge test incorrectly. And looking at the process, we had some ideas. We videotaped the groups doing this. And what we found was that groups that were assigned, that were recommended to divide up responsibility, that they tended to focus on asking questions about unique expertise and making assertions about unique expertise. Whereas the groups that had an integrated system, they were more likely to share information and coordinate that information based on their shared knowledge, and that led to better performance. So it seems that there does need to be some information shared to avoid errors in teams, and it really depends on the task. And I guess the jury is out in terms of what information actually needs to be shared in the team for it to be effective. So we're continuing to think about those issues as well. So the second question is, what errors are based on members' perception of the transactive memory system? And this is structure areas. And this is some of the thoughts based on this are from an earlier paper that was published in Word Science that kind of provides the theory. I don't want to really go into it given the time. I want to make sure we have time for discussion. But one of the important dimensions that David Brandon and I were thinking about in terms of thinking about transactive memory effectiveness was that there are different ways that you can think of transactive memory effectiveness. First of all, the degree of accuracy. So to what extent do people in the team, how accurate are they in terms of who knows what in the team? Are people's perceptions accurate? And they range from accurate to inaccurate. And then the degree to which it's shared in the group. So do I have the same sort of view of the transactive memory system as Ethan? And that can range from shared to idiosyncratic. We may have, in the transactive memory system of the team, we may have very different views about what information is shared and what information is not shared. I mean, what information each member has in the team. And the last dimension is validation. So the degree to which people actually accept their responsibility on the team. So if Steve is the expert on statistics, to what degree does Steve on the team answer questions related to statistics? Because in many kind of situations where you have very busy experts, people may or may not respond to questions and participate given their expertise. So anyway, the ideal state of a transactive memory system is where you have people accurately know who knows what on the team, that people have shared perceptions about who knows what, and that people participate in the system based on the notions of expertise. So they accept their responsibility. So we define, in some of this work, transactive memory errors as deviations from this ideal transactive memory system, given the knowledge of members in the group. So there's a huge assumption that we're making in this work, and that is that taken together that members have sufficient knowledge, skills, and resources to do their individual and group tasks. Because of course there's going to be a lot of errors and problems and negative consequences in the team if you don't have adequate staffing for the task. Okay. So I just want to talk for a second about each of these different types of errors. So there's accuracy errors, and when members' perceptions are not accurate. And one thing that's really interesting is this. I love this. Is one of my favorite pictures of all time, and one of the reasons is because this is when I was on the faculty of the psychology department at the University of Illinois. This person is the administrative assistant to the head of the department. And in her office, she has a little sign that says, "Do you want to talk to the one in charge or the one who knows what's going on?" And so a lot of times, people who are in support roles in the team know more than, for example, the PIs, or know more about the people in charge about what's really going on. And so this is an example of an accuracy error where, some of the people, may, who are in charge may actually not know as much of what's going on as their support folks. So we've talked in our work about sort of the idea of an unexpected expert, where people on the team, there are maybe people based on their demographic characteristics or based on sort of their disciplinary training that may have experts in areas that you might not know about. And we've looked at the degree to which, how difficult it is for people who have unexpected expertise to convince others to accept them as experts. So here's just a quick example. You have someone who's an artist who may know a lot about data visualization because you're very interested in computer science and has a background in it. And you may have an engineer who people expect to know a lot about data visualization who might not know about it. But anyway, so an expected expert, so there's expected expertise and unexpected ignorance, where some people who you might expect to know something actually don't. And so there may be situations where it may be strategic. You may not want people to know that you don't have expertise in an area that people assume that you have. So one of the things we've done in some of our work is to look at when people have unexpected expertise, what does it take to be an accepted expert in a group? So in this study, what we did is we looked at gender and whether or not people had looked at the degree to which people had expertise in areas that were not consistent with gender-based stereotypes. And what we found is that when people had asserted expertise in a particular area that was not related to gender stereotypes, that people very quickly, in a neutral category, that people very quickly accepted that person's expertise and utilized it in the team. However, when people had expertise that was not consistent with gender-based stereotypes, it took a lot of extra knowledge before the team would accept them as experts. And one thing that's very interesting, though, is that when people who have unexpected expertise are able to convince the group that they're experts, and what we found is that people actually had to, assert their expertise more. They had to demonstrate it more and prove themselves that they actually can do very, very well. And this is from my local service dealership where I get my car done. And as you can see, there's one woman who is in charge of service at the dealership, and her line is always the longest. She's by far the most popular person. But I actually interviewed and talked to her in this work, and it took her a very long time before she was able to convince others to put her in this role as a service consultant. So you can also think about unexpected ignorance, and can stereotypes lead non-experts to also become experts? And one of the things that Sam Fraden and I talked about is that sometimes, people make assumptions that somebody might know something when they actually don't know. And for example, Sam, my colleague, was talking about the situation where he was a graduate student and working in the computer lab, and he was the only male that would work late at night. And he told the story of how, the printer would break. And so the women would look to him to fix it because he's the guy. And over time, he actually became an expert on fixing the printer based on that expectation that he was the one to know about it. So in fact, what we argue is that there's a self-reinforcing effect of stereotypes in diverse groups, that sometimes people agree and look to the person who looks like they should know. They may not know, and then over time, they develop the skills and learn how to do it, so it reinforces the stereotype that they know. So anyway, that's as well, and I'm looking at the time, I'm going to move on, but we also found the same thing about cultural-based stereotypes, that in fact, people make assumptions based on culture as well, that, Asian Americans, for example, know a lot about math. And what we found in our work is that even though on a math test, they may not know more than their Caucasian partner, that because they share this stereotype that when they work together, the Asian American gets assigned math-related problems more often than the Caucasian when they even have they have the same level of knowledge. So anyway, I'm going to move on from that. So it's not just gender-based, it's culture-based. Stereotypes can be reinforced as well. So I also want to talk a little bit about sharedness errors. And just very quickly, that when people aren't on the same page about who knows what in the group, that there are really two main types of errors. That people can both do the same thing so that there can be redundancy on the team. And there can also be omission when people think that somebody else is supposed to do it. So both of those errors can lead to problems. And then finally, validation errors, and this is the degree to which people actually participate in the system based on their expertise. And there are a lot of reasons why some people may not participate based on expertise, their expertise in the group. So for example, people may be overloaded with work and information load. They may have a lack of motivation. There may be communication barriers where people can't reach the person who knows. And sometimes this can be strategic as well. So there are validation errors that relate to people not participating in the system to the degree to which they can. And finally, I wanted to spend the last few minutes of my time talking about some things I've been thinking about more recently. And that is when you have a division of labor based on expertise, that errors may be more likely to be missed. So these are kind of process-related errors, what we call. And I wanted to show you a video on which sort of the thinking about this is based. So I'd like for everybody to take a look here and to take a deep breath and to make sure that your complete senses are. So make sure that you're in your complete senses. That doesn't mean, well, anyway, concentrate there. Just watch this. Just watch this. I don't know what that means, okay? So just watch. That's an error. That's an error, right. Yeah. Okay. So, 2, 1. Oh, yeah, I do want the audio. Oh, I don't want the audio on this. Skip bad. So wait, Nacho, where do I get the audio? Oh,
just slide it.
Yeah, I will just slide it.
There you go.
Okay, here we are.
How many passes does the team in white make?
Go!
The answer is 13.
Did anybody get that right?
But did you see the moonwalking bear?
I heard people laughing, so I know some of you saw that. Okay, so this is an area of research that was developed by Dan Simons at the University of Illinois. It's about perceptual blindness. And so I've been thinking about this as an interesting sort of theoretical framework for thinking about errors and error detection when you have experts. And it seems pretty difficult because, first of all, if people are focused on their own areas of expertise, they're not even paying attention to what other people are doing, right? And so if the expert misses something, it's going to be especially hard because the other people aren't really noticing the moonwalking bear, right? Even though it might be a huge problem. And then, so then that's the first part, is they have to even, people outside the expert have to be even paying attention. Now, so that's even difficult, but then the next is that they have to identify it as an error, and perhaps, even if they might see the error, they might say, well, the expert should have caught it. Maybe it's not an error. So they have to convince themselves, because they don't have the expertise or the authority, that, I have to identify that error as actually an error. There, I didn't catch it. And then they have to be motivated to communicate that error to the group. And in a lot of cases, if a low status member who might be paying attention, like for example a nurse, I've been doing some research on critical care teams, and sometimes nurses won't speak up. I know that other people have done, yeah, Amy's over there too, and I've been chewed out for speaking up before, so even if you see what's happening, identify it as an error, the doctor didn't catch it, I've been chewed out, I'm not going to speak up. And then they have to actually influence. So as I talked about, unexpected experts may be discounted. So it's really, really difficult for, in these systems for, I think, that experts, when they make errors, to be identified. So those are some of my thoughts about errors, and I see that I'm going to be actually catching us up again. So I'm going to leave it there. I did want to mention that with these errors, that sometimes, they don't always have to lead to negative outcomes. That in fact, sometimes they might actually lead to some positive outcomes, where people might actually learn things, and groups learn when they make mistakes, and so they may actually improve their procedures over time. So I'm going to leave it here. Those of you who have interest, well, anyway, I'm going to leave it here. So that's it.
Thanks, really great presentation. I'm wondering, whenever we start talking about expertise and influence, it's deeply intertwined with issues of status. And even the nurse example that you just gave is probably a nurse not willing to speak up to somebody higher status, as in a physician. Okay, is there a way that you've thought about disentangling the effects of an expert making an error versus a high status individual making an error?
That's a very good question. I think that a lot of times they often are
correlated,
right? Positively correlated. I think that that's something to look at, because also in teams too, and you think about scientific teams, that certain areas of expertise have higher status. So if you, or in any kind of team, if you're one of the only people who know about a particular topic, that gives you high status as well. And so I think that that's something that I've thought about a little bit. We can chat about it. But I think it's a really important point. That, yeah. Because there's a lot of different ways to think about status. Different knowledge topics, people, their roles in the team, and that kind of thing. So yeah, thank you.
Thanks, Andrea. There seems to be an interesting tie, actually, between this presentation and Brian's. And I was just curious, is unexpected ignorance, as you framed it, the key to his team question? So is it that we expect other bodies of understanding to understand something that they actually don't? And so when we team with other folks, computer scientists and sociologists get together, the sociologists say, well, you mean you didn't know that ... And that leads to some of the innovation and creativity, novelty that he finds. Is that at all an interesting tie?
Yeah, well, I like to hear what Brian has to say about that too. I think that's interesting. Yeah, do you have any thoughts about that while I'm thinking? Buy me some time.
Is it unexpected ignorance, sort of question?
Yeah.
There could be some stereotyping that we have about other disciplines.
Yeah, exactly.
And when we combine knowledge from other disciplines, we may be more willing to accept it as truth when we have a stereotype that that discipline is in fact, the master of that knowledge. And that may help bring novelty into otherwise conventional work. It may make people more likely to accept it. That's one possible tie.
Yeah. I need to think. I'm gonna think more about that. That's a really interesting thought, because it also suggests another benefit for this unexpected ignorance too, that might lead to innovation.
Michael?
sort of following up on that, I mean, it may just be nothing more than a casual analogy, but it does strike me that the way in which error can be a source of knowledge and breakthrough, as in evolution, depends on there not being too much of it. In the same way that novelty is important for success, but only to the extent that there's not too much of it. And I'm just curious to know if you think there's more to that than just a sort of morphological resemblance, isomorphism.
Well, I guess, you know, you don't want to have many errors, and I think that some errors are actually, you know, more critical than others, as we saw in the introductory example. That error was just huge, and that was an issue. Do you have any thoughts about that?
Well, it was kind of
Yeah, I mean,
inspired by the previous
it's
question that
all these
you know,
provocative questions, yeah.
error is useful.
Yeah, it
but
can
not
be
too
learning.
much. And then when we were tying up to Brian, I just sort of thought, and maybe
Yeah.
it's something for you and Brian to both speak to, but I just wonder if there is some relationship between the two. In one case, it's really more sort of combinatoric novelty. And again, they're both analogies in a way to evolution, because there's recombination in evolution and then there's mutation. And so you're sort of showing us the recombination part, and you're showing us the mutation part.
Yeah, well, that's it. Well, that's an interesting insight. So this is an example of this kind of what you were talking about with this novelty as well. All these connections, kind of convention, both of us, and then new ideas. It's interesting.
So, Connie, and then.
Very interesting talk. I think, as you said earlier, indeed, most existing transactive memory research focuses more on how the system works, and indeed the error part is ignored. And I think also at the theory stage, originally transactive memory focused on specialization, which talk about interdisciplinary collaboration. But when you have interdisciplinary collaboration, it's doomed for have a lot of errors because you mentioned the validation. How do I validate another person's expertise when I don't have the expertise to judge, that, like the programming or whatever. So, but then to me, it's interesting combining the research about the success of transactive memory. I wonder to what extent the system can tolerate error. I think you mentioned error in transactive memory, but it seems, that somehow transactive memory can tolerate a lot of error. It's not like you really have to have valid data. But sometimes, even though it's not valid, it's not perfectly developed, but it may still function reasonably well. Maybe the person, for example, I need expertise. Someone to help me with that analysis. I may not be able to get the best expert, but good enough to help me.
Yeah, I mean there is because also exactly that there is some knowledge that is. Like there's certain thresholds of knowledge that some members of the team, this is what you're suggesting, over time you kind of learn what other people know. There may be, you might not know everything about network analysis, but over time talking to people about network analysis, you may learn enough and develop relationships with people who know a little bit to get your problems answered. So there's kind of the interpersonal aspects, and then over time there is some integrated knowledge that develops. And I think that sometimes, transactive memory systems change over time. People learn, oh well, I tried to find out about network analysis and I went to Nosh is too busy, so I'll have to go to somebody else. Okay, so everyone's like, they're laughing, see? Sorry, Nosh, sorry. So then that changes things, and then you have a good experience with the person that Nosh sent you to, and then you tell other people, and then that person develops expertise. And so transactive memory systems are dynamic and changing and adaptive, and I think that's the point that you're making. And so in this theory that David Brandon and I proposed about the development and change of transactive memory, we kind of deal with this issue about people kind of testing hypotheses about what people know and updating them on the basis of the outcomes of their attempts at using the system.
Well,
Thanks.
then who else is there?
Yeah, so as you were talking, it occurred to me that the concept of error really highlights the tension between team level goals and individual level goals, right? Because your discussion of error is at a team level, right? And it could be that you might make an error in assuming I've got knowledge in a particular area that I don't, but in assigning me a job in that area, I actually am learning quite a bit
Right.
in that area, right? And so it's incredibly beneficial for me that that error occurred at the team level, right? That the transactive memory system failed in some sense to promote my individual level learning and ability to do better. But that may be at odds with the effectiveness of the team, because if you had assigned that to someone else initially, the team as a whole might have done better. And so I'm wondering if you just thought about that tension between what individuals might want to get out of things personally, apart from what they want to get out of it as members of a team.
Yeah, I know that's a great point, and that's a really nice way, Paul, of organizing it, because the tension between this sort of errors, you get assigned something, your boss assigned you to something because the other person is too busy, and so it may not be best for the team, but it's good for you, and then over time it helps. And so that's why at the outset I was suggesting that, errors don't always lead to negative consequences. And I think this idea about the tension between individual level, sort of goals and team level is a nice way to think about it. So thanks.
So that's the printer example that you gave, right? The feedback to
Yeah.
the person who learned how to solve
Yeah.
printing problems.
Yeah, so the person, who was so it's a self-reinforcing thing. So the person actually learned and then became a very valuable member of the late night computer lab work group.
And it could certainly go the other way, right? That somebody could decide it's in my best interest for the team to make an error and not give me something that I am expert at, right? Because I don't want to be expert in this area anymore. I'm sick of doing these kinds of jobs.
Exactly, and you know what, thank you for mentioning that, because one of the things, and I had it on a lot of slides, that a lot of this can be strategic. I mean, people have reasons for, like you said, I don't want to do this anymore, I'm sick of being a printer, someone else needs to do it, I don't want to be called in the middle of the night how to fix a printer. So yeah, so there's a lot of strategic, maneuvering, I think, that happens in these systems too, because, there's power associated with different knowledge areas and learning things. And then there's also, you feel overwhelmed sometimes. You think someone else should do something. So I think that's a really important point, that a lot of this can be strategic as well.
John?
Just a comment, just to
Yeah, thanks.
throw something to react to, is that I think a lot of times people talk about TMS systems as all or nothing kinds of things, and that we have these specialists or we don't. But I think about them as there may be bodies or domains of knowledge for which you really want deep expertise, but then it creates a vulnerability in that that's the only person who is responsible for bolting the satellite down. So I wonder about different configurations. You want to go networks, or you want to go different kinds of position sharing, so that if we have these different nodes of expertise, well, we may want to have a secondary one. We want to have that backup kind of person who is the communicator. Or what we may want to have is a centralized node who's basically the communicator. A project director who is making sure the pieces are actually talking to one another when they want to, or a shared mental model at a different level. So I was just wondering if you could speak to the hybrid kinds of TMS, other kinds of configurations that could compensate or create a balance point.
Yeah, thanks for that question, John. I think it's a really important issue, because when we talk about integrated knowledge, there needs to be some knowledge that everybody has in order to function. And you talked about a couple things. One is, you can have a person who has meta-knowledge, who is that serves as, the go-to person if somebody has a question. Well, how can I find out about this? And who can work on that? And I think that's one way to do it. And so, when we were talking about this accurate and inaccurate and validated versus unvalidated, I don't think it's all or nothing at all. In fact, and I think this is where a network approach can be very useful, because within a transactive memory, within a team, people have, subgroups form. Some people maybe work more with other people. And so I think that it's really important to kind of think about, even in a that there are, relations among the members, and that, subgroups develop. And I think it's really important to think about other kinds of configurations. So, and then also other forms of transactive memory, like you were saying, with the meta cognition person as well. So yeah, so thanks.
Luis? So this is probably changing the context a little bit, but because we are talking about error, I think it's also an interesting aspect. So I've been working with critical care physicians, and in the context of their activities, errors is a deviation from a protocol that may or may not put the patient at risk.
Right.
And when I think about doing research, each specialty or each field has sort of a protocol of how to approach problems. And to me, one of the most interesting things when I have collaborations with other people is the idea that I want to understand what they are doing, right? It's just, yes, you have an expertise in this other area, but I want to figure out what is going on. And I end up asking a lot of dumb questions. And I enjoy it when the other person asks a lot of dumb questions about what I'm doing. And the reason why I think this is very important is that I think fields have a tendency to fall in this kind of local optima, and they get trapped. So at some point they thought that something was impossible. Maybe because when it was originally thought, computers were too slow. And then this is still ingrained in the field, that something is impossible. And then you talk with someone else and they start questioning the assumptions that make you think that that's impossible.
Yeah.
And then it releases you from that trap, and actually you can make advances. So it's I think error as a deviation of the right way to do things can also be very powerful in releasing you from places in which you think there is only one way to do this, but actually there could be others that could give rise to new potential. So I always think that teamwork, when people do not think about just separation of skills and of tasks, but actually think in terms of understanding at least the basics, can actually have this effect of unstucking a field from a wrong place where it got trapped.
Yeah, and thank you for that insight. I think one of the things that's very interesting is that those sorts of questions seem that in a large scientific interdisciplinary team that's coming together for the first time, that kind of process seems to be really important. Where people, because in a sense, it's like when you ask the dumb questions, matters, and it seems like, some teams in terms of conventions and, we talked about unexpected ignorance, is that over time, people kind of expect that people should know what I do, for example, and I think that those silly questions might be less likely to happen late, but if there's a situation in the beginning where we all sit up and sit down and let's ask all of our silly questions, I think that actually could be a really good sort of process thing for a team. So yeah, thanks, that's great.
Okay, I think we should call it break time here. And again, let's give a round of applause to Andrea.